Okay, here's question 5, and if you found question 5 challenging, I bet you're not alone, because it wasn't so easy. It was easy to make a mistake, and there's lots of work through it all. Now, some parts it's easy to pick up some marks, but it was not so easy. The first thing, you're supposed to let f equal g. So if you just went 2 cos x equals tan 2x, you're off to a good start. Now, if you knew tangent was sine over cos, you're off to another. That's pretty good. And the sine of 2x, there's only one thing you can do. It's 2 sine x cos x, like that. Now, this is, hey, I did something silly. I have to be careful. If you divide by cos x, you'll lose solutions. You'll lose stuff. And you know cos x could be 0, so you don't want to divide by stuff like that. You don't want to divide by unknowns here because there's solutions in them. If you make this equal 1 minus 2 sine squared, something really good happens. Because you multiply it across and you get this 2 cos x and 1 minus 2 sine squared here. And you get 2 sine x cos x. If we subtract it and put it on this side, then something kind of special happens. Look, 2 cos x and 2 cos x, it's a common factor. And it comes out, we get the cos x all by itself. And hey, that's good because it's like one factor in a bracket that we can make equal 0 and get solutions. And what are we left with? 1 minus 2 sine squared, and then minus sine x. You see, 2 cos x times minus sine x gives me this minus 2 sine x cos x. Ooh, this is really nice. What happens here if we divide by, say, we divide both sides right here, right in this thing here. What if we divide by a negative? Well, let's just multiply this, both sides by a negative. Multiply this by a negative. That'll make that 2 sine squared plus sine x minus 1. That just makes it nicer to look at. We're allowed to divide both sides by 2, and 2 divided by 2 is 1, 0 divided by 2 is 0. Hey, that's looking pretty good. Ooh, that looks like a trinomial that we can just factor. In fact, it does work. 2 sine times sine is 2 sine squared. 2 sine times plus 1 is 2 sine x. And we put a minus 1 here to make minus sine x. 2 minus sine, oh, that all works out. Now we have 3 little packages, 3 little factors we can all make equal 0, and here they are. Cos x equals 0, sine x equals a half, 1 over 2, and sine x equals minus 1. Well, all of these things have solutions. When is cos equal to 0? Well, it's at 90 degrees or 270 degrees, it equals 0. But it's kind of easier just to go 90, and every 180 degrees, it's 0. So this is one general solution, 90 degrees plus k times 180. It's a sort of shorthand way. You could do the plus or minus 90 degrees and times k times 360. It gives you the same thing. But if you go shift sine of a half, it tells you it's 30 degrees. And then there's another answer, 180 minus 30, that's 150. Plus k times 360. And for negative 1, it's 270 degrees plus k. There's all your general solutions. Now, how many can we get to go between minus 90 and 90? Well, you've got the 30 there. If we go 90 minus 180, we get the minus 90. And if we let that equal 0, we get 90. Well, those are the 3 solutions where these 2 graphs, 2 cos x and tangent 2x, are going to equal each other. That's where they're going to cross, and that's what we need in the next question. But that's enough thinking for one question, 5.1.